Hey guys, welcome back to my channel, and today we're going to be proving the partial derivatives of this function with respect to x and y using the limit definition of partial derivatives of a function of two variables. So why don't we start with the partial derivative with respect to x. So the limit definition is just limit as delta x approaches 0, f of x plus delta x minus this over delta x. And as you can see, it's very similar to our functions of one variable, except instead of h, it's a delta x. So let's just prove it now. So, whoa, sorry about that. So if we actually plug in our variables, so instead of x, we're going to do x plus delta x, plus y, and then minus just f of x comma y, which is what we already have. And this might look a bit confusing how to do, but all we have to do is actually conjugate it, and it becomes relatively simple afterwards. So remember, a conjugate is just like, if you're subtracting, you would do the conjugate and just multiply by adding the two terms. So in this case, it would be root x plus delta x plus y plus root x plus y. And because we need to multiply by only one, we can only do that. We need to make the denominator and numerator this conjugate. So the numerator becomes a difference of two squares. So we get x plus delta x plus y minus x plus y. And the bottom just becomes delta x times our conjugate, which was this. So these cancel out, x plus y minus x plus y cancels out. And then our delta x actually also divides, so these cancel into a 1. So we're left with limit of delta x approaches 0, 1 over root x plus delta x plus y plus x plus y. And if we just substitute delta x for 0, we get 1 over root x plus y plus x plus y, root x plus y, which is just 1 over root 2 x plus y. So yeah, so now we're going to do the same thing except find the partial derivative with respect to y. And again, the limit definition is exactly the same, except our delta x becomes a delta y because we're taking it with respect to y. So, oops, sorry about that. Yeah, delta y minus fxy over delta y. So again, we're just going to plug in what we need. So this becomes x plus y plus delta y. And then this is the same function over delta y. And again, we're going to conjugate. So let's conjugate. So x plus y plus delta y minus root x plus y times the conjugate. So plus root x plus y instead. And then our top simplifies very well because of the difference of two squares. So we get x plus y plus delta y minus x plus y over delta y, x plus y plus delta y plus root x plus y. And again, we get a lot of cancellation, and then also we can divide the two delta y, so more cancellation. And we get the limit as delta y approaches 0 of 1 over root x plus y plus delta y plus root x plus y. And if we substitute delta y directly for 0, we just get 1 over 2 root x plus y. And as you can see here, the partial derivatives with respect to both variables are actually the same. So yeah, thank you for watching.